And we are live, guys. Who's going to be the first to join, guys? Who's going to be the first to join? Okay. Welcome, guys. Welcome, welcome. Hope you're all well. Hello, hello. Hello, hello. Welcome, welcome. Who's going to be the first to join, guys? Okay. This has been my third live today. Okay. Who's going to be the first to join? Hello, Keo. Hello, user 123456. Welcome, welcome. Hello, hello. Guys, let me know. Can you hear me? Is it all clear on your side? Hello, Kia. Welcome, welcome, guys. If you're new around here, make sure you press that follow button, okay, and check out the content on my video. Okay, this is actually the third live today. Probably actually the last live actually for today. Okay, okay. Kia can hear me. Okay, brilliant, awesome, awesome. Okay, when we hit, guys, when we hit 1K likes, we will start the live, guys. So get tapping, guys, on that screen. Okay, when we hit 1K likes here, we'll obviously start today's lesson. Okay, today's video, not video, sorry, today's live is a slightly more different live. Okay, this is like a preparation, okay, for your upcoming paper one exam actually. So this one, is aimed at AQA, but it's also appropriate for EdXL paper one higher tier and also OCR paper four higher tier for the OCR students. Okay, that follow me. Okay. So it's appropriate for the non-calculator paper for GCSE Maths. Okay. Hello, Heidi. Welcome, welcome. Thank you, Kia, for liking. Thanks so much, Kia, for liking. Hello, Abzi. Welcome, welcome. Thank you, Kia, for liking. Guys, we will start very, very, very shortly, okay? So, while you're actually waiting, guys, okay, think about and write down as much as you can. What about EdXL? Well, this will also be appropriate for EdXL too, but I'll do a separate live for EdXL here as well, actually, okay? But this is also appropriate for EdXL as well, okay? Hello, Wizzy Life, welcome, welcome. Some comments actually got through that. Actually, give me 1 second, guys, just so I can see the comments. Sorry. Were there any comments or not? I can't really see any comments. It's alright. Thank you, Kia, for liking. Guys, when we hit 1K likes, we always should make a start, okay? So, the paper one exam, guys, little tips and hints that I'm going to give actually here. Paper one is testing your mental maths knowledge. So it's testing your knowledge of obviously times tables. Okay, it's testing your knowledge on the rules of surds. Okay, laws of indices, your square numbers, your cube numbers, your prime numbers. Okay, fractional indices. So knowing obviously these obviously numbers. Okay, product of prime factors. Okay, lowest common multiple, highest common factor. Okay, standard form. Okay, hello Ryan, welcome, welcome Ryan. Hello, hello, hope you're well. Hello Devin the Danger. Hello, and thank you Kia for liking. Guys, if you're not, sorry, if you're not already following me, make sure you press that follow button. Hello Jacob, hello, Wizzy Life, welcome, welcome. Hello Zane. Okay, we will start, guys. Okay, in just a few seconds. Here we go. Okay, so 1K likes ready. Okay, so let's start. Okay, so square numbers, remember, guys, are made by multiplying a number by itself once. So 1 squared is 1 times 1, which is 1. 2 squared is 4. 3 squared is 9. Okay, so on and so forth. Okay, so learn your square numbers. Oh, thank you so much, Keo, for the rose. Thank you so much for the rose, Keo. Thank you so much. I appreciate that. Thank you so much. Okay, any gifts, guys? Yeah, are of course you're welcome actually. But thanks so much, for the gifts today. I appreciate that. Thanks so much. Okay, guys, make sure you press that follow button, guys. Yeah, as we do today's live. Okay. Oh, thank you so much for 1.2K likes, guys. We're smashing it. Anyway, sorry, I actually digressed there. Okay, so square numbers are made by multiplying a number by itself. So 1, 4, 19, sorry, 1, 4, 9, 16, 25, 36, 60, 64, 49, 81, 100, 144. Okay, okay. AQA specifically want you to know your square numbers between 1 and 15. Okay, for editor and OCR, yeah, it's a bit more different. Okay, but learn these square numbers for all exam boards. Okay, that is my advice here. Okay, cube numbers are made by making a number multiply by itself twice. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. Okay, 3 times 3 times 3 is 27. Okay, so on and so forth. Okay, again, learn your first 5 cube numbers, I would say, and then obviously learn 10 cubed. Okay, and obviously learn your prime numbers. Okay, hello G5. Welcome back, my friend. Hello, hello. Welcome back. Okay, so guys, are there any questions so far about this part of the course? Okay, so paper one, remember, is testing your mental arithmetic knowledge. Okay, hello user 217-606-8944. Hello Sammy, welcome, 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 welcome. Hello Simon Sharif. Hello AJ. Guys, make sure you press that follow button, please, before we leave today. Hello AJ, welcome, welcome. Okay, so let's start today's lesson. Okay, so it's looking at mixture of questions. So first one is looking at multiplying decimals. So work out 0.16 times 38. So if it was me, okay, I would do 16 times 38 and then divide my answer by 100. Okay, to make it easier for me. Okay, so working this out, guys. Sorry about this, guys. I apologize. Sorry about any. I don't know why it actually does that. So I'm so sorry. Okay, it's a pain when it actually happens. Oh, it does that again. Okay, okay. I'll just deal with it. Okay, so I'm gonna do 6 times 8, which is gonna be 48. So 8, carry the 4. 4 times 1 is gonna be sorry. 8 times 1 is gonna be 8 plus 4 is gonna be 12. So the first part is gonna be 128. Okay. The next part I'm gonna put a placeholder. I'm now gonna do okay. Yep, spot on, Q. Yep, that is correct. Yes. Okay. Oh, yep, spot on. Okay, 6 times 3 is going to be 18, so 8 carry the 1. Okay, 1 times 3 is 3, plus 1 is going to be 4. So I've got 128, and I'm going to add that to 480. You well done, Q. Yes, that is spot on, correct. Yes. Sorry, guys, about this. Yeah, I've got no idea why my actually computer is doing this. Well, thank you so much, Q, actually, for sharing the live machine. Thank you so much for sharing the live out. Hello, Soph, Ella's version. Welcome, welcome. Hope you're well. Okay. So, okay, you are right, Q. Yes, it's gonna be 8. Plus 0 is gonna be 8. 2 plus 8 is gonna be 10. Okay, 1 plus 4 is gonna be 5. Plus 1 actually is gonna be 6. 6 so 8. Okay, right. I'm now gonna divide my answer by 100. So, can someone tell me in the comments why am I dividing my answer by 100, please? Okay, because 608 is not quite my final answer, is it? So we're dividing it because to go from 0.16 to 16, I've multiplied by 100. Yep, spot on, Q. Yes, that is correct. Yep. The final answer will be 6.08. Why is it doing this today, guys? It's so annoying. I'm so sorry, actually. I'm so sorry. So annoying. Why is it doing this? Yes, spot on, Q. You are correct. Yes. Why is it doing this? Let, let's just change colour and see if it makes a difference. Oh, sorry. Oh, wait, what? Does that make a difference? Oh, does it make a difference? No. Okay, so 6.08. Okay, that, guys, is going to be our final answer. Well, doing histograms at some point, yes, I will be, yes. Hello, Cammy, welcome, welcome. Hello, Bikers for Life. Okay, Does that make sense, guys? Does that make sense? Arrow options. Hello, dude. 721. Okay. Again, this is a very, very common question that appears at the start of an Edexcel or like an AQA higher tier paper. Okay. So multiplying decimals. Okay. There's my answer, 6.08. Okay. Okay, next question, guys. Which card has the greatest value? So I'm looking at some arithmetic here. Okay, so adding, subtracting, multiplying, and dividing fractions. Okay, so let's do multiply first, yeah, because it's a bit more easier. Okay, 3/4 times 2/5. So I do top by top, so that'll be 6, and then 4 by 5 is 20, so I get 6/20. Okay, right. Okay, dividing fractions, I use the KFC method. Okay, so I'm going to do the keep, flip, change. So we keep the first fraction, we get 3/4, we multiply that by the reciprocal. So we flip that, okay, we get 5/2. Okay, and then we change it to a times. Okay, now we do top by top. So 3/2 is going to be 15, and 4 by 2 is going to be 8. So I get 15/8. Okay, so straight away, this one is not actually the biggest. Okay, so I can cross that off. Okay, because that one's going to be bigger. Okay, okay, spot on, Q. Yes, you're spot on. Yes. Okay, when we're adding fractions, we want a common denominator. So we're going to cross multiply. So I'm going to do 3 times 5, which would be 15, plus 4 times 2, which would be 8. And then over the product of the denominators, I'm going to have 15 plus 8 over 20. So I'm going to have 23/20 on the top. Okay. Hello, sir. Welcome, welcome. Okay, so 23/20. Okay, for that one. Okay. Thank you, sir, for liking. Oh, thank you so much, sir, for the roses. Thank you so much for the roses, sir. Thank you so much for the roses. I appreciate that. Thank you so much. Thank you so much for the roses. Okay, so that's going to be 1 and 3/20. Okay, so far. Okay, and then subtracting fractions again. I want a common denominator, so I'm going to cross multiply. So 3 by 5 is going to be 15. Okay, subtract 4 by 2, which is going to be 8. So all over the product of the denominators. Okay, so 4 by 5 is going to be 20. So I'm going to have 7/20. Okay, so it can't be that one. So it's either the top left one or it's the bottom right one. So which is going to be my answer, guys? So let me know in the comments below, okay, which one is bigger, 23/20 or 15/8? Okay, so as a mixed number, that'll be 1 and 7/8. Now I can clearly visibly see that 7/8 is bigger than 3/20. Okay, so this one's going to be my final answer. Okay, does that make sense, guys? Yeah, let's move on then. Okay, there we go. Okay, okay, next part, guys. A fraction of an amount. Work out 3/8 of 48. Okay, so I divide by the bottom and times by the top. I divide by the bottom times by the top. So 48 divided by 8 and then multiply that by 3. Okay, so 48 divided by 8 is going to be 6. 6 times 3 is going to be 18. That's how to work out a fraction of an amount. Okay, so divide by the bottom times by the top. Hello, Harry teacher, welcome, welcome. Hello, Samilia, welcome, welcome. Hello, Layla, welcome, welcome. Hello, hello. Guys, if you join you guys here, make sure you give us a follow, please, yeah. Press that follow button if you can, guys. Okay. Next question. Hello, Callum, welcome, welcome. Right, 48 as a fraction of 600. Give your answer in its simplest form. So it'd be 48 600ths. They're both even, so I can divide it by 2. So I get 24 over 300. They're both even again, so I can half it or divide it by 2. So I'm going to get 12 over 150. They're both even again, so I can half it. I'm going to get 6 out of 75, or 6/75. And then I would then lastly divide top and bottom by 3, so I get 2/25. And that would be my fraction in its simplest form, okay? So don't do it, guys, here in like one go. Do it bit by bit, obviously help you, okay? Hello, Dan, welcome, welcome. Okay, hello, Kenny, welcome, welcome. Okay, that's that one there. Okay. Write 0.13 reoccurring as a fraction in its simplest form. Okay, so reoccurring decimals to fractions. Again, another big topic on the AQA non-calculator paper and also Excel. So we let x equal 0.1313, sorry, 0.13333333333, so on and so forth. Okay. We then are going to work out what 10x is. So 10x, so multiply both sides by 10. I'm going to get 10x is equal to 1.33333333333333. Okay, so on and so forth. Okay, I can now look and say, okay, well, if I subtract these, okay, I label this as 1, label this as 2. Okay, if I do equation 2 subtract equation 1, I'm going to get 9x on the left-hand side. On the right-hand side, actually, it's slightly more actually trickier. On the right-hand side, actually, I'm going to get as follows. Well, they're going to cancel. They're going to cancel. They're going to cancel. They're going to cancel. So all these are actually going to cancel. I've got 3 take 1, which would be 2. Decimal point goes there. 1 take 0 is going to be 1. I've got 9x equals 1.2. Okay, x equals 1.29. Okay, so I've multiplied top and bottom by 10. Okay, and I'm going to get 12/90. Okay, but it wants it as a fraction in its simplest form. Hello, Rowan, welcome, welcome. Okay, because they're both even, I can half it, so I get 6/45. Oh, you Rowan, that's awesome, my friend. That's awesome. Well done. Nice one. That's awesome, buddy. Awesome, awesome. That's good, actually. I'm glad to hear, actually. Well done, my friend. Okay, so we get 6/45. Divided top and bottom again by 3, and we get 2/15. Okay, again, this topic here is quite a hot topic on the paper one actually exam. Okay. Oh, that's awesome, Rowan. Well done, actually. Well done, buddy. That's awesome. Hello, Gareth B. Hello, Imogen. Welcome, welcome, Imogen. I hope you're well, Imogen. Welcome, welcome. Okay, does that make sense, guys? Okay, so that's reoccurring decimals to fractions. Yes, I'm good, thank you. This is easy, awesome, awesome. Yeah, no worries. Okay, this is obviously for higher tier maths, remember. Okay, sorry about my handwriting, it's not that hard. Okay, cool. Okay, next question, guys. 7% of the batch of 18,000 are faulty. How many are faulty? So again, percentage of an amount. So I'm gonna work out what 1% is. So 1% means divide it by 100 to be 18,000 divided by 100. Okay, so knock off two zeros, so it'd be 180. Okay, and then to work out 7%, I'll do 7 lots of 180. So 180 times 7 to work out what 7% is. Yep, spot on, Imogen. Yes, spot on. Okay, spot on. Okay, so multiply it by 7. Okay, 0. 7 times 8 will be 56. So 6 carry the 5. 7 times 1 is going to be 7 plus 5 is going to be 12. So it's 1,260 components are faulty. Okay, and that, guys, is my final answer. Okay, make sense? Okay, awesome, awesome, awesome. Modern imaging, yes. Okay, okay, next one. Laws of indices. Okay, first question, guys. What do I do when I multiply with the same base? Can someone tell me in the comments? So when you multiply with the same base, what do you do with the powers? Okay, no worries, Imogen, no worries. Worries. Hello, Peter. Welcome, welcome. Giving you a couple minutes here to work it out. Guys, if you're new here, please, please, please hit that follow button, okay? Follow me, guys, yeah. And check out my content on my page, please. Hey, please, if you can, help me reach 3K followers, okay? That is my target. So please, please, please press that follow button if you can. Yeah, no worries, Imogen, no worries, Imogen, no worries. No worries, okay. So here, we're going to add the powers because we're multiplying with the same base. So 6 plus 10 will be 16. Then divide it by a squared. No worries, yeah, no worries, Imogen. See this? Take care, Imogen. Okay. When we divide, we subtract the powers, okay? So it'd be a to the power of 14, okay? So just to be clear, guys, yeah. So I've done a to the power of 6 plus 10 minus 2, okay, to work out my answer, okay? Which is a to the power of 14. Make sense? Yeah, let's move on then. There we go. Okay, so standard form now. So converting into standard form. So the key, remember, the key when it comes to standard form, it's a number between 1 and 10 times 10 to the power of something. If it's a big number, then it's 10 to the power of a positive number. If it's a, if it's a decimal, then it's a negative power of 10. So this first one, it will be 3.65, okay, multiplied by 10 to the power of something. And that power will come from here. So it's 1, 2, 3, 4, 5 jumps. So it's 5 jumps. 3.65 times 10 to the power of 5. Okay. So it's 5 jumps, guys. Yeah, it's 5 jumps. Okay. Does that make sense, guys? So start here. You go 1, 2, 3, 4, 5. There we go. Okay. Okay. This next one, get a number between 1 and 10. So it'd be 1.24 multiplied by 10 to the power of what? Well, here it's going to be a negative because I've got a decimal here. So I'm going to go 1, 2, 3 places. So it'd be -3. Okay. And that's pretty much how standard form works. It's a number between 1 and 10 times 10 to the power of something. Okay. This next one, let's work it out. We're going to have times it by 10 to the power of 4. So it'd be 1, 2, 3, 4. Okay. This next one, power of -4, it will be 0.00076. Okay. For that. Okay. So does that make sense, guys? Let me know. Make sense? So they're the answers on White Rose Maths. Hello, Tiffany. Welcome, Tiffany. Hello, hello. Okay, so now adding, subtracting, multiplying, and dividing in standard form. Okay, when we add, we've got two options. We either convert it so it's both whole numbers, and then obviously add using the place value method, or convert it so it's the same power. Okay, so same base power. So here I can multiply by 10 cubed. Okay, so I'm gonna have 8,000 here, but to keep it the same, I'm gonna multiply by 10 cubed. So I got 8,000 times 10 cubed. Hello, hey Tiffany. Yeah, no worries, no worries, Tiffany. No worries. Hey, thank you for the follow, by the way. Thanks so much for the follow, Peter. Hello, Alex. Okay, so 10 cubed plus 4 times 10 cubed. I can now just add the numbers. So I'm going to have 8,004 times 10 cubed. Okay. Or I can write it as 8.004. Okay. Multiplied by 10 to the power of 6. Okay. So does that make sense, guys? Okay, moving on. Okay, so here I'm subtracting. Okay, again, two options. Convert it so it's both whole numbers. Do the subtraction using the subtraction column method with the correct place value, or convert it into so it's both actually the same base. So to make it easier, okay, I'm going to make it so I'm going to have 8,000 times 10 cubed here. Hello, Tia. Welcome. Okay, so I'm going to have 8,000 times 10 cubed. Subtract 4 times 10 cubed. Okay. So that's going to be what? That's going to be 7,996 times by 10 cubed. Let's have 1, 2. I'll write it in standard form actually. So I'll write it as 7.996 times 10 to the power of 6. Okay. For that. Make sense? Okay, multiplying is a bit more easier, so I times the numbers together and just add the powers together. So 8 times 4 is going to be 32. So it's 32 times 10 to the power of 9. Okay, I'm going to add the powers together, okay? That'll be what? That'll be 3.2 times 10 to the power of 10, okay, in standard form. And again, this is a super, super common question, guys, on the paper. Okay, dividing similar. Okay, I divide the numbers. 8 divided by 4 is going to be 2. And then 10 to the power of 6 divided by 10 to the power of 3. I'm going to subtract the powers and have 2 times 10 cubed. Okay, so that'll be 2000 as a whole number. Okay, either option would suffice. Okay, that one, okay. It doesn't actually say obviously work out here, so it doesn't actually say yeah, write it in standard form. Okay, so I'll put it in here in SD here to like make it obviously for like good actually practice here, but there's no harm in doing that. Okay, either way. Okay, hello Peter Jackson, welcome, welcome. Hello, hello. Okay, okay, so they're the numbers here in that format. Okay, right into this form. Okay, so looking at some surds now. Root 15 this year times root 12. Okay, now to make it easier, okay, what I'm gonna do is I'm gonna write it as the square root of 3 times by the square root of 5 multiplied, okay, as root 3 times root 4. Okay, so now we know as follows. Root 3 times root 3 is just 3. The square root of 4 is equal to 2. So I've got 3 times 2 times root 5. So if I simplify this, I'm going to have 6 lots of root 5. I'm going to have 6 root 5. Okay, there we go. Okay, so looking at the equation of a line. Okay, so again, step 1 is to work out the gradient. So the gradient is the change in y over the change in x. Okay, so it will be m is equal to the difference in y, so -2 subtract 4 all over 3 minus 0. Okay, I'm going to have -6, so -6 thirds, which is equal to -2 or -2. Okay, so now I'm going to have y is equal to mx plus c, so y is equal to -2x plus c. But we know that it passes through the point 0, 4, so c is equal to 4, so it's y is equal to -2x plus 4. And that is my final answer. Okay, does that make sense, guys? Let me know. Okay, that is my final answer. Hello, Matt. Welcome, welcome. Hello, Maisie. Welcome, welcome. Welcome back. Okay, so that's looking at, yeah, straight line graphs. Okay, so the key to remember, you work out your gradient, okay, then you work out your y-intercept, okay? Thank you, Matt, for liking. Thank you, user, for sharing. Thank you, user, for sharing. Okay, next part now. Okay, there we go, or 4 minus 2x. Okay, solving equations. Okay, if it was me, I'm going to subtract 10p on both sides to balance each side respectively. Hello, primary maths. Welcome, miss. Welcome, welcome. Hello, hello. I hope you're well, miss. Hope you're well. So we get 3p is equal to 15. Dividing both sides by 3, we get that p is equal to 5. Okay? Hello, Miss M. Welcome, welcome. Hello, hello. Okay, there we go. Okay, so now yeah, it's a bit more actually trickier now. Okay, so to work out P and Q in this identity. Okay, so step one is to multiply out the brackets and then collect your like terms. So we're gonna have 3px. Okay. Hello, Z's ice cream. Welcome, welcome. Hello, hello. Okay. Plus 3 lots of y, which would be 3y, minus 2x, minus 10y. Okay. That's equivalent, i.e. the same as 4x plus qy. Okay. So expand the bracket there. Okay. Okay. So now collecting like terms. So I've got 3y minus 10y, so that'll be 7y. So I'm going to have 3px minus 2x minus 7y is equivalent to 4x plus qy. Okay. Hello, Shaheen. Welcome, welcome. Okay. So now I can say, well, 3p minus 2 is equal to 4. If you compare the coefficients of x, so 3p minus 2 is equal to 4. And if you compare the coefficients of y, minus 7 is equal to q. So we know that q is equal to minus 7. Okay, straight away. Okay, if you compare coefficients of y. Okay, if we solve this, so we add 2 to both sides and then divide by 3, we're going to have that p is equal to 6/3, so p is equal to 2. Okay, answer for that. Okay, again, a super, super hot topic on a paper one exam, guys. So your non-calculator exam. That's a super, super, super hot topic, okay? Especially for AQA. Okay, there we go. Okay, so writing is a single fraction, so algebraic fractions. Okay, so I'm gonna cross multiply. So I'm gonna do 1 times n plus 2 minus 1 times n minus 1 over the product of the denominators. So I'm going to have 1 lot of n plus 2. So I'm going to have n plus 2 subtract 1 lot of n minus 1. Okay. Over the product of the denominators. So n minus 1 and n plus 2. Okay. It is not actually the KFC method here. So this method here, so KFC, that is when you're dividing fractions. Okay, so dividing fractions is KFC. Okay, when you're adding or subtracting fractions, you want to have common denominators. Okay, so expand the top. I'm going to have n plus 2 minus n plus 1. Okay, oops, sorry there. Sorry guys, I apologize. I'm getting a bit tired now. I do apologize. What I might do here is just stop in like 5 minutes here and just have a little bit of a break. All over n minus 1 times n plus 2. Hello, Kirst. Welcome, welcome. Okay, so the ends are going to cancel. 2 plus 1 is going to be 3, so I'm going to have 3 over n minus 1 and n plus 2. And that, guys, will be my final answer, okay? I don't know why it's doing this little line thing today. It's so annoying. Okay, there we go. Okay, bang. Got there in the end. Okay. Okay, factorizing a quadratic. Again, I've got loads of videos here on this topic there. Okay, to factorize, we want a double bracket. Okay, x and x go in both. So x goes there and x goes there. Hello, British Supertutor. Welcome, my friend. Welcome, welcome, sir. Welcome, welcome. Okay, we want two numbers that add to make -5 and multiply to make -24. Okay, so they will be -8 and +3 because -8 plus 3 makes -5 and -8 times +3 makes -24. Okay, again, that's a super common question, okay, on exam papers for GCSE math. Okay, so revise, okay, factorizing quadratic shape, a super common question, okay? There we go. Okay, rearranging formula, okay? So to make A the subject, so rearrange V is equal to U plus AT to make A the subject. I'm going to subtract U on both sides. We have V minus U. Hello, ML. Welcome, welcome, ML. Okay, is equal to AT. Dividing both sides of my equation by T, we get V minus U all over A is equal to T. And that, guys, is my final answer. And that's how to rearrange a formula. Okay. Make sense, guys? Make sense? Any questions? Hello, user. Welcome, welcome. Okay, there we go. Okay, which is the graph y is equal to 5x minus 3? Okay, so it's got a positive gradient, so it can't be this one and it can't be this one because they're both negative, and it has to pass through the y-axis at -3. So it's going to be this option here, okay? For that, okay? There we go. Okay, sketch the graph y is equal to x squared plus 5. Okay, so that'll be a U-shaped graph passing through the y coordinate or y point of 5. Okay, it would look something like that, okay? Okay, what do these features of a speed time graph represent? The gradient of the line, well, that'll be the distance. Is that right? Sorry. Let's have a look again. So speed time. Yep. No, sorry. Sorry. The area under the graph here is gonna be so the area would be the distance, okay, or distance traveled. Okay. The gradient would actually be the acceleration. Okay. Hello, theme parks. Welcome, welcome. Hello, hello. Okay. So it'd be the acceleration. Okay. There we go. Okay. Shade the region where y is greater than x plus 2. So let's plot the line y is equal to x plus 2. So when x is 0, y is 2. When x is 1, y is going to be 3. when x is 2, y is equal to 4. When x is 3, so it looks something like this here. So it looks something like this, guys. Okay. Looks something like this. Okay, sorry guys, I'm going obviously a bit fast today. I apologise. Okay, so it's a straight line. Okay, with your ruler. Okay, we want the region where y is greater than x plus 2. So let's pick a point. So let's pick this point here, 2, 1. So when x is 2, y is 1. So is 1 greater than 2 plus 2? Well, no, because 1 is not bigger than 4. Therefore, we want this region here. Okay, so that is my answer, guys. Okay, hello, soy sauce, welcome, welcome. Okay, there we go. Okay, the first two terms of a Fibonacci sequence are A and B. Write an expression for the fourth term. So Fibonacci sequence here is a special type of sequence where the next term is the previous two terms added together. So it'd be A plus B is the third term. The fourth term will be B plus A plus B, so that'll be A plus 2B. So the fourth term is A plus 2B. Okay, that's your fourth term. Bang. Hello, Ethan. Welcome, welcome. Okay, this ratio in its simplest form. Okay, divide them both by 100 first. So we got 9 to 120. Then divide them both by 3. So we get 3 to 40. Bang, there we go. 12 buns weigh 420 grams. How much will 20 buns weigh? Okay, so we want to work out the weight of either 10 buns or 1 bun to make it easier. So if we divide this by 12, so 420 divided by 12, okay, so 12 into 4, I can't. Oh, why is it doing this today? This is so annoying. Like this little. 12 into 4, I can't do. 12 into 42 will be 12, 24, 36. So it goes in 3 times with a remainder of 6. And 12 into 60 goes 5 times. So 1 bun weighs 35 grams. So I'm going to do 35 times 20. Okay. Well, 35 times 2 is 70. So times it by 10 again. So it'd be 700 grams. Okay. And that is my answer. Okay, there we go. Okay, which is not a condition for congruency. Okay, it will be, okay, and yeah, it is going to be angle, angle, angle. Okay, all the others are types of congruency. Remember, you got RHS. Hello, Alice. Welcome, welcome, Alice. Hello, hello. Yep, spot on. Yes, Alice, you're right. Yep, Alice, you are correct. Yes. Okay, remember the rules, guys. Yeah, remember it's RHS, ASA, so angle, side, angle. Okay, right angled hypotenuse, side, 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 and then side angle, side. Okay, thank you, Alice, for liking. Thanks so much for liking, Alice. Okay, there we go. Okay, how many faces does a triangular prism have? Okay, so triangular prism. Okay, I think it has one, two, three. Is it five? I think it's five. Yes, it is 5. Yes, spot on. Okay. Oh no, it's actually 5 years. So think about it. So remember, something like this. Yeah, a rough drawing. Yeah, it looks something actually like this. Okay, it has one. It has a face there, doesn't it, Alice? Yeah, it has a face there. A face on this side, and on the bottom. Okay, so think of it as like a Toblerone bar. Okay, it has five faces. Okay, okay, looking at some trig now. Okay, so exact trig values. Okay, so to work out the side of, yeah, does that make sense, Alice? Yeah, so I'm going to a bit fussy. I apologize. Hello, Scarlett. Welcome, welcome. Okay, does that make sense, Alice? Does that make sense? Okay, okay, cool. So looking at some trig now. Okay, so label my sides. That will be the adjacent. That'll be my opposite, and that'll be my hypotenuse. So we are looking at SOHCAHTOA for 3D, sorry, for right angle triangle, sorry. So SOHCAHTOA. Okay. Yes, it is GCSE, Scarlett. Yes, it is GCSE, yes. Okay. Yes. So this one's looking at questions that could appear on like a non-calculator exam, okay? So these are questions that could appear on the AQA non-calculator, like higher tier exam. Okay. I'm year seven. Oh, do not panic yet, Scarlett. Yeah, do not panic. No, do not worry about it if you're in year seven. This is aimed at year 11, actually, revision. Okay. So do not panic, Scarlett. Yeah, do not panic. Okay. Hello, Maisie. Welcome, welcome. Hello, hello. Hope you're well. Okay. So we've got an addition and a hypotenuse. So we're going to be looking at co or ca. Okay. So we're going to have cos of the angle. So cos of 30 is equal to the adjacent over the hypotenuse, is equal to x over 16. Okay, multiply both sides by 16. We're going to have 16 cos 30, okay, is equal to x. Okay, anyone know what cos 30 is here? It is an exact trig value. Okay, so I think it's root 3 over 2. So it's going to be 16 root 3 over 2, which simplifies to 8 root 3. Okay, so x is equal to 8 root 3 centimeters. Okay, there we go. Bang. Okay. Right, area of a sector. Give your answer in terms of pi. So the area of a circle is pi r squared, and then we multiply that by the angle over 360. So it'd be 60 3/60ths, okay, multiplied by pi r squared. So times by pi, times by the radius squared, times by 12 squared. Okay, so let's obviously simplify this to make it easier. This inverts to 1/6. We're going to have 1/6 times by pi. Hello, Lucy. Welcome, welcome. Times by 12. So let's to make it a bit easier. Times by 12, times by 12. Okay, we're going to do 12 divided by 6, which will be 2. 2 times 12, so that's going to be 24. So it'll be 24 pi centimeters squared. Okay, that, okay, that's my answer for that. We go. Okay, which vector is parallel to a minus 2b? So parallel means it has a scale factor. Okay, so it can't be this one. Okay, because the both actually doubled there. Okay, it can't be this one because one of them, yeah, has been doubled and the other one stayed the same. It has to be this one because I've halved both of the numbers. Okay, so think of it as 1a. Okay, I've halved everything, and it can't be this one because one's been halved and one's been doubled. Okay, there we go. Okay, so show the region inside the parallelogram here that is closer to B. Okay, so I'm looking at some construction here. Okay, so it's going to be there. Okay, okay. So looking at some frequency. Okay, commutative frequency. Okay, so we're going to start with 12. 12 add 23 is going to be 35. Okay, that take away that is going to give me that. Okay, so that plus that is going to be 80. So what is 62 minus 35? 2 take 5 I can't do, so I need to borrow. Okay, 5, 1. 12 take 5 is going to be 7. 7 take 3 is going to be 2. So it's going to be 27 there. Okay. Remember, here we add up the frequencies as we go along here. So we're adding up the frequencies as we go along, okay? There we go. Okay, use the Venn diagram machine to work out the probability of A and B. So A and B is this part here. So it'd be 4 out of the total, which is 7 plus 4 plus 10 plus 12. Okay, 7 plus 4 is going to be 11. 11 plus 10 is going to be 21. 21 is just going to be 4 out of 33. So 4/33. Okay, okay, looking at some tree diagrams now. Okay, so yeah, complete the actual thing. Okay, so we're gonna have 0.8 here because probability has to add up to make 1. Okay, here's gonna be 0.4. Here is gonna be 0.4 again. Okay, 0.6. Okay, this is what I call a tree diagram. Hello, Miss M. Welcome, welcome. Okay, so this is what I call a tree diagram. Okay, and then what we call independent. So independent just means that whether the bus is late or on time does not affect whether the train is late or on time, actually, if that makes sense. Okay, so yeah, for that one. Okay, there we go. Okay, the probability that a seed grows into a flower is 0.8. How many seeds in a packet of 500 flowers would be expected to grow? Okay, so this is called the expected value. Okay, into flowers, it would be 0.8 multiplied. Hello, yes, I'm back on that. Actually, I'm back on, yes. So 0.8 times 500. Okay. Any gifts, by the way, guys? Yeah. Any gifts here are actually welcome today. So any gifts be greatly actually appreciated, guys. Yeah, if possible. Okay. Let's work this out. Hello, GCSE and A-level tutor. Welcome, welcome, sir. Hello, hello. I hope you're well, sir. Hope you're well. Hello, hello. Okay. So 8 times 5 is going to be 40. Okay. So think of it as doing 8 times 50. Okay. Because that's actually the same sum here. Okay. So that should be 400. Okay. Hello, Aaron. Welcome, welcome. Okay. So be 400. Oh, thank you, sir. Thank you so much, sir. That is so kind of you. Thank you so much, sir. I appreciate that. Thank you so much. Thank you, sir. I appreciate that. I'm very kind. Guys, guys in the chat here, anyone actually follow me here, please check out Sir's past papers here. So Sir's made some fantastic prediction papers here. Okay, please give Sir a follow, guys, here, and check out his papers here. So check out his papers if you can. Okay. Thank you, Sheen. Thanks so much, sir, for liking. Thanks so much for liking. Okay. Oh, thank you so much, sir, for the roses. Thanks so much for the roses, sir. Thank you so much. That's so kind of you, sir. Thank you so much for the roses. Thank you so much, sir. That's so kind of you, sir. Thank you so much. Thank you, you legend. Thank you so much, sir. That's so kind of you, you legend. Thank you so much. Thank you so much, sir. Thank you so much. That's so kind of you, sir. Thank you so much. Hey, okay, next one, guys. Okay, so going obviously quite fast today. Okay, the next one. The probability of A is equal to 0.3. The probability of B is 0.5. The probability of A and B is 0.35. Are events A and B independent? Explain how you know. Well, the probability of A and B, okay, if I do 0.3 times 0.5, I get 0.15. Okay, that's not the same as 0.35. Okay, so because they're not the same, okay, value, okay, these would be classed as independent, okay? For that. Hello, V. Welcome, V. Hello. Long time, V. Hello. Hope you're well. Hello. Okay. Okay, so sorry, actually, yeah, sorry. Okay, so the answer is no, sorry, okay? So they are not independent, actually, yeah. So for them to be independent, okay. Hello, Imogen. Welcome, Imogen. Hello. Um, I did PPE and got off. Oh, awesome. Well done. Awesome. That's really good, actually. Well done. That's awesome to hear. Hello, Imogen. Hello, less than 3. Welcome. Okay, there we go. Okay, so that is the end of today's PowerPoint, guys. Okay, so we'll finish there actually for today. Okay, are there any more questions, guys? Are there any more questions? I just need to get my revision for this year, and hopefully, awesome. Yeah, I'm sure you actually smash it. I'm sure you actually smash it. Okay, I'm sure you will actually. Yeah. Okay. Let me just write it again actually because it's not very neat there. Okay. So guys, yeah. So for independent events, the probability of A times the probability of B equals the probability of A and B. Okay. Right, guys, we'll finish there actually for today. Yeah. So finish there. Yes, that is right. Yep. So mutually exclusive. Yep, that is actually correct. Yep. Okay. So they are what we call, yeah, mutually exclusive events. That is correct. Okay, spot on. Right, guys, I'll finish actually for now. Okay, I'll catch you all later actually. Thanks so much for actually joining, guys. Thank you for all the gifts. Okay, see you all very soon, guys. Okay, thank you so much for watching. Okay, take care, guys. And I shall see you very soon. Okay, bye for now.